So for question 4, it's asking Model 3 accounts for how much more variance in final exam score than Model 1. So basically, this question is it's asking us to compare Model 1 and Model 3, um, or how much better is Model 3 at explaining students' final year score compared to Model 1. So this question is about improvement in prediction, not specifically individual predictors. Like the other questions have been. This is literally just like which model is better. So to do this question, we have to find the R squared value. We find this because R squared tells us what proportion of variance in the dependent variable is explained by the model as a whole. I know it's kind of confusing. It's basically just telling you how much of the variance in the dependent variable, so when the dependent variable changes or, when it's manipulated, how much of that variance is explained by the model as a whole, like the model itself, all the different variables in that model. I know it's kind of confusing, but this is why we need R squared for this, because R squared is going to help us compare Model 1 and Model 3. The formula then to this question is R squared Model 1 and R squared Model 3. They're not multiplied, they're literally just like you find the value for R squared in Model 1 and then find the value for R squared in Model 3, because each of the models will have an R squared value. The reason we do Model 1 and Model 3 instead of Model 2 is because Model 1 has working memory capacity only as a variable, and then Model 3 has working memory capacity, first year examination, and GPA as variables. So we're comparing like which is better at predicting. Basically, that's what we're comparing, like one with the less amount of variables and one with the most variables, basically. So that's the formula. So I'm going to do out the question now, and then after we do this formula, we're also going to convert it into a percentage. So to do this question, we're going to go down to this table, and we're going to find the R squared. So we're going to go to this one here, and we're going to go R square, and we're looking for Model 1 and 3. So it would be 0.769 for Model 1 and 0.859 for Model 3. So I have that written down here, 0.769 and 0.859. What you do then is you go Model 1 minus Model 3, so 0.769 minus 0.859, which is 0.09. Then you convert that into a percentage. You do ignore the signs in this instance because you're just looking for the difference between these numbers, not like plus or minus. So the answer then to the question 4 is 9%.